Hey students, good morning. This is Mr. Fukao again. This is Thursday morning. Gosh, I miss you guys already. I hope you guys have a great day, okay? So this is just the second day of chapter 3. Just a reminder that your next quiz is scheduled for Wednesday, next week Wednesday, September 11th. I think this is someone's birthday in one of your classes. I forget who. And also your homework assignment is due tomorrow. I checked online and some of you have already submitted it. Good job. Good job, and you completed it. Make sure you get 100% on your assignment. There are unlimited retakes on that, so if you miss a question, go back and fix it. There are a couple of you that turned it in who did not get 100%, so go back and fix those mistakes, all right? So I want to just begin again. On Tuesday, the video watch on Tuesday, we talked about categorical variables versus quantitative variables. And quantitative variables, remember, it's not as simple as just saying if it's numerical, it's quantitative. Examples are area code, zip code, your student ID number. Those are categorical, okay? Quantitative is a measure or a count. Time, distance, weight, height, how many you have of something, how many responsibility tickets you have, how many letters you have in your first and last name combined. So consider this question. In what class were the Titanic passengers? We're going to go back to that example that we talked about on Tuesday that pretty much is consistent through chapter 3. So on the Titanic, there were 4 possible class options. You were either first class, second class, third class, or you're part of the crew, okay? So when you respond to this, you have first, second, third, or crew, okay? So this would be categorical. Now, consider this question. Did each passenger survive or not? If I asked you this question, just think about it. If I asked you the question, what would your response be? It would either be a yes or no. It would be a did survive or did not survive. It would be alive or dead, right? So this would be alive or dead. Sorry, this is such a morbid example, okay? So on page 24, you're gonna see something called a contingency table. Now, contingency table is also known as a two-way table. I believe your textbook just calls it a contingency table, but a lot of other textbooks and a lot of other resources may call it two-way table. Same thing. Two-way table because you have 2 variables, okay? The ones we just described. Now, are these variables, first, second, third, crew, dead and alive, are they categorical or are they quantitative? You should clearly be able to see that they are categorical. A person is either first class, second, third, or crew, and the person either survived and is alive or dead. Okay, so this is just straight up copied out of your textbook. All right. So let's just analyze this data here. There were 2,201 total passengers on the boat. You could see that a lot more died than survived. And if you look at this, the group with the class with the largest amount of people were the crew, 885 out of that number right there. First class was the smallest. So we're going to answer some questions here. First question is, what % of passengers were in the second class? Okay, so we're looking only at the second class right here. So the way I want you to write this is we're going to use P parentheses second. Now, can you guess what the P stands for? You guessed it right. It's probability, okay? Or proportion or percentage. So since all 3 of those words start with P, we use P. So the probability of someone being in second class, when I write this as a fraction, is 2201 is a total, right? And there were 285 people. Now, if the question just asked for what proportion of passengers were in second class, this answer would be sufficient. However, since it asked for percentages, we're going to change it to percentage. So I'm going to get my calculator. All I'm going to do is just do 285 divided by 2201. and I get 12.95%. Okay? Went around two decimals after the, or two places after the decimal place. Okay? Now, what percentage of passengers died? So now we're looking at the dead row right here. So the probability of dead would be still at a total of 2,201 and 1490. That's a large portion. It's going to be like what, 2/3? 1490 divided by 2201. I got 67.70%. You guys verify that? I'd be so embarrassed if I messed up on these answers. If I did, please don't laugh, okay? Just correct them. What percentage of passengers were in second class and died? So now this keyword "and" here tells us we're looking at people that were second and died. So we're looking at 167. So the probability of someone being second, okay? And I'm gonna introduce you to a new symbol. This right here means "and", second and dead. Okay. So this means "and". Okay. Would be the intersection of that column and row would be 167 over 2201. So 167 divided by 2201, 7.59%. Now, next question, what percent of passengers were in first class and survived? Because I always thought about this. I wonder if people that were in first class had like a higher survival chance because they're on their first class passengers. So, probability of first, and there's an "and" word again, and survived, or maybe we should write alive. Let's see, so first and alive, there were 203 over 2201. 203 divided by 2201, 9.22%. Okay. So this gets me thinking, as I mentioned in part D, like, were there a higher proportion of people in first class who survived than like third class, right? Because wouldn't you think so? Remember Leonardo DiCaprio, he was like third class, right? And then Rose, I think her name was Rose McGowan. No, I might be making that up. But Rose, Kate Winslet, she was first class. She had that nice, pretty red diamond thing. Okay. So let's examine that. So we're going to have our first introduction into what we call conditional probability. Let's talk about this for a moment. So it's on page 26. On page 27, they describe it. It shows the distribution of one row or column. Okay, so we're looking specifically at just one row or column. So what I want to know, the question that I had was, did being a first class passenger give you a higher chance of surviving, of staying alive? I don't know, what do you guys think about that? Think about that for a second. Right, like these people probably paid more for this ship, they were higher class. Would they, I don't know, did they get the lifeboats and life jackets before everyone else? Okay. So the question is, of those who survived, what percentage of them were first class? So for this one, looking back at my data, okay, so when you see this statement here, of those who survived. Now, we don't care about those who died. Okay, we're not taking into consideration this column right here. So I'm going to cover that up. Just look at the live. So how many total survived? So the probability, and this is going to come up more in chapter 14, I believe, but I'm just going to show it to you anyways. The way we write this in probability notation, in proper notation, would be first given that you were alive. Okay, this symbol right here represents given. So given that you were alive, what proportion of those people actually were in first class? So this would be 203, and it's not going to be at the grand total, because again, we don't care about those who died. So we're only looking at the 711, and then 203 divided by 711 would be 28.55%. Okay? So what if I wanted to compare that? Back to my question of, did being in first class have a higher chance of surviving than being, let's just say third class. So of those who, is it okay if I use ditto marks right now? Ditto marks just mean it copies the sentence above it. Those who survived, what percent of them were first, should this be those? What percent of those, whatever. I'll write those right here, were third class. Okay. So now, third class, the probability of third, given that they were alive, they survived. Okay, so this would simply be 178 over 711. So 178 2201, oops, 178 divided by 711, 25.04. Okay. So let's say you're a family member of someone who died on the Titanic. Like, would you have an argument right here that you had a higher chance of surviving if you were first class? I don't know, you tell me, okay? Another interesting one to look at, maybe we were looking at the wrong data. If you did the same thing, right? Instead of saying of those who survived, let's look at of those who died. Okay, if you, I need a sheet of paper. Okay, let's just do it right here. Of those who died, what percent were first and third? Let's just do those together. So the probability of first, given that you were dead, and then the probability of third, given that you died. Remember to pause this video so you can work these problems out. I'm just gonna keep going because YouTube takes forever to load the longer the video is. So I'm looking at 122 divided by 1490. So I'm just looking at the dead column right here. So 8.19. Okay, let's look at third and died. So 528 divided by 1490. Oh my gosh, we're onto something, guys. 35.44. Wow, there's a higher percentage of people who died were in third class than first class. Now that's a problem right there. I wonder what happened on the night that the Titanic sank. Okay. All right, so next thing is I want you to take a look at page 28, just checking. So go ahead and pause this video right now and answer that right now, okay? Go through questions 1 through 7. And then you can check your answers on page, where was that? Page 44. So page 44, answers. Okay. Go ahead and work through those. And I want to talk about number 6 and number 7 specifically. So let's skip over those. Check your answers. Do all of them, but check your answers in the back. So let's look at number 6 right here. Compare the percent of those who are female among blue-eyed students to the percentage of all students who are female. So we want to compare the probability of female given that you have blue eyes versus the probability of being female. Okay. So for this one, so this would be female and blue would be 4 out of 10. It would be 4 out of 10. So this would just be 40%. And what's the probability in female? This would be 32 out of 64, right here. And this would be 50%. Okay. So in number 7, what they're saying are they independent? Okay. So we're comparing these two numbers. We're comparing this 40 to 50%. What they're asking is, if we knew that a female had blue eyes, like, does that tell us anything about, I'm sorry, if we knew a person had blue eyes, does that tell us anything about their gender? Like, would that give us a hint, right? So think about this. It looks like it's 50-50 right here. There's half 50, 50% males, 50% females. But notice that for blue eyes, it's not 50%, it's not 50%, it's not 50% right here. So there must be something telling us that your gender could tell you something about the color of your eyes. Okay? So look on page 28, the explanation right there. It says, in a contingency table, when the distribution of one variable is the same for all categories of another, we say the variables are independent. So if these were all 50%, 50%, 50%, just how this is 50%, then we would say yes, they're independent. So this would be no, they are not independent. Just like as I mentioned earlier with this notation, this is going to come up more in chapter 14. This is kind of like a sneak peek, okay? A trailer, if you will. Read that definition over on page 28. Basically, if this was, let's see, if this was 5 and 5, and this was 18 and 18, and this was 9 and 9, then we would say, yes, they are independent. Independent, yeah. But since they're not, we would say, no, they're not independent. Okay, guys? I'm about 2 hours away from my surgery. Wish me luck. Have a good Thursday. Bye-bye.